kinds of people who are going to be speaking. And our next speaker, I'm not sure which one he is, but he might be from another planet, so I'm just giving you a warning. And if you Google the biography of Walter Cruttendon, which I did some time ago, it popped up, "Are you interested in bizarre history?" That's what popped up with Walter, just so you know, because they're reading everything, of course. And I think that you might need to know the following bit of information. And somebody here told me that the Dalai Lama has been searching for over a year to talk to 3 people. And 2 of them are here at CPAK. And our next speaker, Robert Grant, is one of them, and the other is Alan Green. And the other is Nassim Harriman, who works with them on some of these esoteric projects that are way over my head, but we're going to learn a lot more about. And I would just like to ask you what you think. What's your guess of why the Dalai Lama would want to talk to Alan Green, Robert Grant, and Nassim Harriman? My guess is that the 3 of them are building a consciousness spaceship and going to take off and leave the rest of us behind. That's my guess, you know. But I think it's really wonderful to see. Okay. I'm going to give you 10 minutes to think about all this and to do some deep breathing before you come back. Amen. Hallelujah. Okay, are we ready to continue our journey into outer and inner space? You know, one of the things, I went to a lecture that was given by Walter Cruttendon not so long ago about the Yuga system and cyclical history, and he was saying that in the lowest age, you know, the Greeks called it the lead, bronze, silver, and golden age. And so it's both an Eastern and Western thought, but in the lowest age, the Greeks said this was the age of man, mental thinking, mankind, with all of our separation and limitation. The next age that we will be moving into, they call the age of the hero, and we're starting to see that, I think. More individuality, more creativity, more thinking outside of the box, room for diversity. And the next age is the age of the demigod in the Silver Age, and in the highest age is the age of the gods, according to the Greeks. And so can we even imagine what it's like when the state of humankind is so empowered and so collegial that we actually see ourselves as co-creators with the gods? Doesn't that sound real, you know? That we are all participants, that we can even fathom this idea of oneness that we're trying to beat into our heads. And I think it's very encouraging if you look at the scriptural messaging in the West, like look in the Bible. In the Old Testament, one of the cardinal messages, one of the 10 commandments was, "Thou shalt not kill," right? Well, by the time of Jesus, which was 1,500 years later, or 1,200 years later, roughly, the message is, love your neighbor. That's a big difference than don't kill him to love him, right? And now, only 2,000 years later, we're starting to flirt with the idea that we are our neighbor. Isn't that a lot of progress in a short amount of time, you know? To go from don't kill him to love him to you are him. So I think we should congratulate ourselves that we are on the move and in the right direction. So now, Robert Grant, and afterwards you and I can discuss out in the hallways whether he's from another planet. We'll see. I don't know. Robert.
Thank you. Thank you, thank you. Can everyone hear me okay? Okay, great. I'm super excited to be here. And today is actually the 2-year anniversary of my first trip to Egypt. And actually, some of you were there. Can you raise your hand if you were there? Yeah, quite a few of you were there. And Nassim Harriman had asked me to give a presentation there of my work on mathematics and also on spirituality to a certain extent. And so I prepared this presentation that ended up going way longer than I thought it was going to go. It went about, I think, 3 hours or something because I had so many questions. And I was shocked because I was giving a presentation on math, and at the end of the presentation, like half the people in the room were like teary-eyed and crying. And it had such a profound impact on me personally. And then we all experienced this incredible evening where we spent the night in all three of the pyramids in Giza. And I have to say, it's been exactly 2 years, and it was my first time to give a presentation on something like this. Having been a business person for so many years, what a dramatic shift this has been, and the last 2 years has been just amazing for me. So I just could not express to you any more than I can today how grateful I am to be here. So I'm going to talk to you today about, a language. Now, I went to MBA school. I studied international business. I've lived in 9 countries. And I worked predominantly in the healthcare industry for about 25 years and had gotten all the way through, the CEO of a large corporation called Bausch & Lomb, which maybe many of you have heard of. And you're probably thinking, how in the heck did a CEO of a pharmaceutical company end up here on this podium? Well, that's a longer story, but I will say that all of us go through profound shifts in our life, and I think that's what life is about, is to learn to evolve. And actually, Alan Green and I are going to be presenting today at 1 o'clock on that evolution as well. And this is a picture that we all know very well, which is the Vitruvian Man, and some of the discoveries we found related to that and what Da Vinci was trying to tell us that relates back, again, to the Great Pyramid and our own conscious evolution. Okay, so how many of you think that 360 degrees in a circle is arbitrary? Like, someone just chose, I'm going to make it 360 degrees in a circle. Well, actually, it's completely not arbitrary. And we could get that answer just by looking at radians, and so you could kind of come to the conclusion that 360 degrees is not arbitrary. But the way I came to that conclusion was related to Fibonacci and how Fibonacci math basically adds upon itself. And as you sort of take Fibonacci numbers, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5. So then you get this sequence of 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and so on. And it just keeps building. And this is how nature tends to manifest itself all around us. And we see this pattern over and over and over again. Well, we also see it in circles. Now, we know that the golden angle is 137.5 degrees. And if you subtract 137.5 from 360 degrees, you end up with 222.5 degrees, approximately. 222.5 degrees happens to be 0.618 of 360 degrees. Now, what is 0.618 and why is that important? That is the ratio that separates each of the Fibonacci numbers in their sequence. It's the golden mean. So, if I give you an example here, my arm from here to here is 0.618 of my arm from here to the end of my fingers, okay? Now, this is true for so many different parts of our body, and that's actually what the Vitruvian Man's trying to tell us as well, that there is this golden mean relationship across everything we see in nature, even ourselves. And so when you start looking at these numbers, you go 360 minus 222.5, right, gives us this relationship of alpha. If I subtract alpha, or what I'm calling here the golden angle, so phi minus 137.5 is taking me down to 86. So 86 relates to light speed as well. So light speed is 186,000 miles per second. And also our sun has a diameter of 864,000 miles. It's that same 8.6. You'll see this repeating over and over again. If you just take, in mathematics, you can take kind of 1 off the front of things and add it back all the time. And that's a very important relationship as well. Then I take 86 minus, or if I take 137, subtract 86 from it, I'm at 51. Well, that's the pyramid slope angle. And then I take 51, I subtract 35, I get 16. Then something very strange happens. I then go to the next number, 51 minus 35, gives me 16. 35 minus 16 comes back to 19. So interesting mirror here, right? And 6 is just an upside down, backwards 9, I guess you could think of it like that. But 360 degrees is absolutely fundamental. So I started doing work on the Great Pyramid and started looking at, and this is before I even knew at all who Alan Green was. And I started looking at the ratios and the proportional dimensions of the Great Pyramid, and I found that literally every one of the proportional dimensions and the measurements themselves were mathematical constants. And I thought, how is it possible that all these incredible math constants are coming out in the Great Pyramid with such perfection? Even this length right here of 718 feet, right, along this line, that relates to the Euler number, which is 2.718. And 2.718 is also the basis for the sacred cubit, which is 1.718. So, in fact, if you looked at it, if you had a circle with a radius of exactly 1 meter, 30 degrees of arc on the circle with a radius of 1 meter would have exactly the length of a sacred cubit as its length of arc. And if I swung a pendulum from that, and I swung it at 30 degrees, it would take exactly 1 second for the plumb bob or the pendulum to swing each direction. So the meter and the cubit, all of these systems of measurement we use are all fundamental to how the Great Pyramid was built. In fact, if you look at it, the Great Pyramid happens to be on a latitude of 29.9792458 exactly light speed. That's exactly the degree for its latitude position. And it's the identical number. If you don't believe me, just Google it. You'll find it. Just Google it, light speed versus the latitude of the Great Pyramid. But a lot of people don't know that even the longitude is actually relational to light speed, because it ends up at 31.1342 degrees. And if I take that 31.1342 and divide it into 36 or 360 degrees, just move the decimal position 1 over, that ends up being 0.864 of 360 degrees. And that's why we have 86,400 seconds in 1 day. So both the latitude and the longitude are light speed measures. One is in meters, the other is in miles, just simply by taking the 1 off the front of light speed. So phi ends up as a positional reference point. And you could think of it as the math constants themselves aren't actually all these separate things, just as we perceive ourselves as totally separate from each other. Yet in mathematics, we teach it as a constant. You know, people memorize pi. They memorize pi to how many digits? Like thousands, tens of thousands of digits. People actually take the time to memorize pi to tens of thousands of digits because we think that pi, in its transcendental irrationalness, is so special, it's so unique. And yet, is it really? Or is it just a mirror reflection of how we look at the number 1? And that's what we're going to talk about today. Because even 360 degrees is really just 1 turn of 1 circle. So we have these fundamental math constants. Now, what if there was a relationship between these fundamental math constants and music? Okay. So I started looking at it and noticed that pi itself, there's a language here, right? And you have to look at this like a pure linguistic perspective, to really dive into it. You would look at it and say, all right, I'm going to separate this out and say, what if the 3 in 3.14 was actually just 3 turns of a circle? So 1, 2, 3, brings me back to the top. And then the 1, 4 would land right here, which would land me right at 51 degrees, right along this circle. Everyone follow me so far? So it's the 0.14 that really matters the most, right? Because that's the positional point that I'm going to land on. Then the next thing would be double that, which would take me to 86, right? 51 takes me to 102 degrees. So it would basically be this position right here, which would be 0.28, right? So 0.14 times 2, 0.28. And that happens to be a position called tau. So tau is 2 pi. So 3.14 would become 6.28. But the 6, again, is just 6 turns of the circle. Okay? Then the next position would land me right here, where I have this f. And this is what we call rho. And that is a mathematical constant as well. Then we have another one here called gamma, which is the Euler-Mascheroni number. Then we have Euler, and we have light speed here. So this would be 0.86 approximately. So now we have actually all the notes, the whole notes, in a scale, starting with D, E, F, G, A, B, then back to C. So it's basically going 1/7. How many notes are there in a scale? Whole notes, there'd be 7, right? 7, the 8th would begin the next scale. And actually, each of these positions is pi, another math constant called tau, another math constant called rho, another one called the Euler-Mascheroni number, which ends up being exactly 0.577, another one, which is 0.718, which is that Euler number from the 2.718. Because remember, it's just 2 turns of the circle. Landing at the 0.718 is what matters the most. And then light speed coming up here at 0.86, which would be 6 divided by 7. So 1/7, 2/7, 3/7, 4/7, 5/7, 6/7. Now, the Euler number plays this other role where it actually gives you the half note positions. Because we know we have a chromatic scale, right? We have sharps and flats in our scale. And Euler is the 2.718. Well, if I take 0.71, I multiply that by 2, I end up with 0.14 with a fraction behind it. So the Euler is always working in combination with pi itself. And in fact, if you do this, you can write this down if you like. The Euler number controls compound interest. So if I borrowed, or if I loaned you $100,000, and you're paying me 6% interest, we have this thing called the law of 72, where I can do simple math to figure this out, how long it's going to take for me to double my investment in you. So all I do is I just take the interest rate that you're paying, and I then put that into 72 to see how many times it goes into 72. So if you're paying me 6% interest, how long will it take me to double my money? How many times does 6 go into 72? 12 times, right? So 12 years for me to double my money. And this takes into consideration compound interest. This is what banks do when they basically calculate your interest. This is the maximum exponential growth that can come out of this investment, right? Now this 72 is related to that 718, right? It's just rounded to 72. Now what's interesting about this is that if you take Euler number, which is 2.718, and this is where that 72 comes from, the 0.72, and we take 2.718 and we multiply that by 1/3, so 0.333333, and then put 4 on the end of it. And then you take 3.14 and you multiply that by 2/3, so 0.6666667 at the end of it. And then add those two numbers together, guess what you get? Not quite. So I'm taking a weighted average, right? So it's basically 2.718. I'll draw it out for you. So 2.718, 2818 times 1/3, right? Plus 3.14, 15926 times 2/3 equals, anyone know? It's called a weighted average. 3.000. So Euler and pi actually work together to create light and darkness. And this is fundamentally embedded right in the Great Pyramid, and it can't be missed. And they're actually just creating musical notes because everything we experience in mathematics and in the universe is actually just this beautiful symphony playing all around us all the time. So numbers of the alphabet, constants, mathematical constants like Euler and pi and phi, the golden mean, and alpha, and all these other math constants that we hear about are the verbs of expression of this language. And circles and geometry organize the sentences, the syntax of this language. So imagine that we've kind of been playing with mathematics in the same way that, let's say you had learned, so the Korean language, I speak Korean. I lived in Korea for 2 years. And the Korean language is a totally phonetic language, right? So it's called Hangul. And you may have seen the symbols. You go to a Korean restaurant or something like that. They're kind of very basic and simple looking. They don't look difficult like the Chinese characters do. Chinese characters have a lot more detail in them, right? But what if I told you that the entire Korean language is based on Chinese? So the root, just like English has the root sort of words that all come from Latin, right? The root of Korean language is actually Chinese characters. And they use the Chinese characters in Korea, just nobody teaches them that much anymore, right? But in order to read a newspaper in Korea, you need to be able to understand and know at least 2,000 Chinese characters, because they do use them every once in a while. They're getting less and less so the case. But imagine that you'd only learn the phonetic pronunciations for these Chinese characters, right? And you never knew the true meaning of the actual Chinese character, like the hieroglyphic demonstration of that. But you just simply could speak the language. We've been doing the exact same thing with mathematics. We're missing the message, completely missing the message. There's an entire language that speaks to us very clearly and succinctly and beautifully and simply if we actually take the time to understand what's underlying that language. And we're not right now. That's the thing that's really unfortunate about the world so far. But the good news is that we're all about to get to a stage where we can understand this new language of mathematics. Because this is the means through which consciousness speaks to us, speaks to each of us. Consciousness is writ with each of these messages of this number. And I'm sure many of us here have experienced a change in how we communicate or how numbers seem to communicate to us. Have you noticed that? Absolutely. So this is the sun. Now, is it pure coincidence? Now, if I had a perfect means to be able to come up with a time system, would it not somehow relate to the sun? Right? If I had the perfect ability to do it. Now, when did the number 86,400, when was that chosen as the number of seconds in our day? And if you just take 24 and multiply it by 60, right? So 24 times 60 minutes times 60 seconds equals 86,400. There's even a song about this. I think Matchbox 20. I can't remember what the name of the band is that does it, but there's even a song about this, 86,400 seconds in a day. Now, do you think it's coincidence that the Sumerians, who came up with this time system, it's as old as our own history, right, of civilization, knew that the sun is exactly 10 times that? Is that just coincidence? By the way, it's that same 0.864 times 360 degrees that gives us the longitude of the Great Pyramid, too. Is that just coincidence? I don't know. And then what about the distance from Earth to the sun? 93 million miles. If I double that to try to find what would be the exact sort of diameter of the orbital, what would that come out to be? 186. Is that back to light speed again? And how fast does the Earth travel around the sun? How fast is our orbital velocity? Anyone know? Would you be surprised if I told you it was 18.6 miles per second? So the Earth is traveling around the sun at precisely 10,000 times slower than light speed. Wouldn't that be interesting to kind of know? And what about the distance of Mercury to the sun? It's 36 million miles. But if I multiply 36 million times the precessional number of 2.592, I end up with 93 million miles. That gives us exactly the orbital position for the Earth. And I can do the same thing with 186 million. I multiply that by 2.592. I'm at 483 now. 483 million is the distance to Jupiter from the sun. These are all harmonic ratios. And why 2.592? Because it's 1.61, again, phi squared. So 1.61 squared is 2.592. Isn't that interesting? So we have all of this, and these are just my hand drawings when I started doing this work. We have all these relationships that point to incredible order. And even the planets themselves, have you ever noticed if you took water off the surface of the Earth, what color would the Earth be? probably the color of dirt, which is kind of like a brownish, reddish type of color. Well, if that's the case, then isn't this just a rainbow? Roy G. Biv? And then each has its own note. And by the way, I'm not the first to say this. Kepler said this. Harmony of the spheres. So did Isaac Newton. They all believed that there was a music and there was a geometry. Kepler's laws of motion also defines why light speed would have a big interaction here. But then you have to ask, well, then how did we know that the measurement systems would all be perfect? That's a deeper question. So here we go. Here's another example. 86,400 seconds in a day. But look at the mean diameter of Jupiter, 86,400. And look at the mean diameter of the Sun, 864,000 miles. The orbital speed of the Moon is 86,400 kilometers per day. And you've got 864,000 kilometers per day for the orbital speed of Saturn. Now, is this all coincidental? And yet we ended up exactly with 86,400 seconds in a day. I tell you what, the people that came up with our time system were absolute genius. I mean, that is incredible. Or maybe is it just writ in the fabric of consciousness? And all of these are harmonic ratios, right? Every single one of these. And notice you'll take 3 cubed and then 2 to all its powers, and you end up with these numbers, 54, 108, 216, right? 432. By the way, 432 squared is the speed of light in miles per second. And so you'll see these numbers over and over and over again. You see 216, right, minutes in a 360-degree compass. 2,160 are the sum of interior angles of a cube. 2,160 miles is the diameter of the Moon. Look at all of this order. It's astounding. So we have an ordering system as well around the number 24. Now, are there 25,920 years in precession, or is it 24,000? I believe it averages out at 24,000 because as we get closer to Sirius A, things speed up. And as things speed up, I believe our average in that point in time ends up going down to 21,600, which is related to that moon cycle. Okay? And as we get farther away, it sort of slows down and goes to 25,920. Now, if we average 21,600 plus, right, do a weighted average, just like we did up there, plus 21,600 and 25,920, then you end up with an average right at 24,000. And that's probably what it is. Now, what's the magic of 24? Well, Fibonacci numbers end up, if you look at them in digital root, and digital root is just a simple mathematical technique. You take a number like 27, its digital root equals 9, because 2 plus 7 equals 9, right? So if I had a digital root of, for the number 13, what would it be? 1 plus 3 equals 4, right? And all you have to do is keep going. This is kind of the same math that you do in numerology, same type thing. But nobody ever wants to look at it in academic circles because they call it numerology. Well, but guess what? Number theorists use this all the time to find and identify patterns. And Fibonacci numbers do this over here. So I mentioned that Fibonacci numbers are 1, 1, 2. So 1 plus 2 is 3. 2 plus 3 is 5. Then 8. Then 13, because 1 plus 3 equals 4. Then it goes to 21. 2 plus 1 equals 3. Then it goes to 34. 3 plus 4 equals 7. Then 55. 5 plus 5 equals 1. You always reduce it down to 1 digit. Now, what's interesting that comes out of this is this pattern repeats itself every 24 numbers. So the Fibonacci pattern repeats every 24 numbers. And not only that, but actually the 180-degree opposites always sum to the number 9. 1 plus 8 equals 9. 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. 4 plus 5 equals 9. 8 plus 1. It just comes to 9 all around. And what's interesting is that if you look at all polygonal geometry, the sum of interior angles will always sum to 9. So 360 degrees, 180 degrees is a triangle, right? Triangle. So what's a square? 360. Okay. What's a pentagon? 540. 5 plus 4 equals 9. What's a hexagon? 720. 7 plus 2 equals 9. Right. What is a heptagon? 900. If you guys know that, then I would give you a prize probably. 900 degrees, and that adds up to 9, of course. Then an octagon is 1080, which adds up to 9. All right. Then you got 1260, still adds up to 9. Then you have 1440, still adds up to 9. Every polygonal geometry and all polyhedra will always sum to the number 9. So also another thing that I noticed was that all prime squared numbers always end up as a multiple of the number 24 plus 1, without exception, if you're going larger than the number 3. So 5 times 5 is 25. That's 1 times 24 plus 1, right? 7 times 7 is what? 49. That's 2 times 24 plus 1. Okay, what's the next one? 11 times 11, we're only looking at prime numbers, right? So 121, that's 5 times 24 plus 1. So what's the next one? 13 times 13? 169, right? That's 7 times 24 plus 1. And you can take this all the way out into infinity, and all prime numbers then end up always being multiples of the number 24. And interestingly, 24 is a special number. It's special for many reasons, but the first of which is that 24 has a reciprocal value. That means 1 over 24. That's how you find the reciprocal value, equals 0.41666. So it actually rounds to 0.42. So the reciprocal is equal to its palindrome. Palindrome means you just take the number and make it turn around backwards, right? So 24 has a palindrome that is 42. So its palindrome and its reciprocal value are the same. Interesting. Of course, you have a decimal position there, but the universe doesn't really care about decimal. Decimal is something that we use as a reference point for where we are. The universe doesn't care so much about it. So what's interesting then is you've got on the flower of life 24 circles on the outer perimeter. Also fascinating. The full flower of life. And then also another thing that I discovered is the square root of 10, which is another way of looking at another root of 1. The square root of 10 divided by 10 plus 1, it's a very simple equation, to the power of 1 over 0.24 gives me pi. So 24 has this relationship to pi and circles, again, too. And then also in reciprocal value, the only number that has 1,000 digits for its period length, if you just put 1 on top of it, is 24,001. Another interesting thing. So 24 is also 4 times 3 times 2 equals 24. And 2 plus 4 equals 6. So the Sumerians came up with the sexagesimal counting system. That's why we have, all of the counting systems that we have even for our imperial units of measure as well, which, by the way, are even more advanced than our decimal systems because it's based on a base 12 system. So the way they would count was based on their knuckles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? That's how they would count. They would use the other hand to sort of track how many of those that they basically added up. So 24 is definitely special. So I then started doing some work on this, and I published a paper. Now, one of the hardest problems that's been around for a long time has been the world's inability to predict prime numbers. Has anyone known that you can actually predict prime numbers now? It's possible now. So I learned in junior high, impossible to predict a prime number, right? How many of you heard that when you were in school? Impossible to predict prime numbers. We don't know what they are. Well, actually, I published a paper in the same Cornell University site that you saw earlier in Walter's presentation. Accurate and infinite prime prediction from novel quasi-prime analytical methodology. So I went and spent 3 nights in the Great Pyramid. The next week, after I had spent 2 nights and 1 night totally by myself, I ended up publishing the precursor to this paper. And basically, this was the work that I did. And what I was looking for was a connection, working with Nassim Haramein, on is there a tie between electricity and gravity? Is there a tie between electromagnetism, radiation, and gravity? Now, Walter Russell has talked about this. Many people throughout history have talked about there must be some connection between the two, but it's been something that's confounded mankind for a long time. So what I was looking for was a number theory approach to understanding how gravity and electromagnetism might actually be interrelated with each other. And maybe there's only one force in the universe, and that's electricity, and the other forces that come off of it are just results of that electrical interaction. So what I found was that on a 24 clock, which is just a spiral of 24, starting here, then going around 24, then 48, then 72, then 96, etc., all prime numbers, which is this reddish-orange color, showed up, except for 2 and 3, in the exact same spokes of the wheel. And it's shaped just like a Templar cross. Now, in addition to that, what I was really interested to find were the numbers at the center of the cross, which turned out to be all the mathematical constants. And their positional reference points versus 360 degrees and 432 degrees, which relates to pentagon and hexagon merger, 6/5 and 5/6 relationship. So for example, 222 shows up right here because 222 divided by 360 is 0.618. It doesn't give you the perfect irrational values, it just tells you where to find those irrational numbers that are in the same very close proximity, because this has no decimals on them, right? These are all just whole numbers as you go around, but it's beautifully ordered. So what I was interested in to understand is that what are the green numbers here? And how do the green numbers work? And what I found was that maybe there would be something that would indicate that it was similar to a prime number, but not necessarily prime. And there's a reason why it wasn't prime, but still there's a reason why it was adjacent to a prime in the same spoke. And it turns out that all the green numbers were divisible only by prime numbers greater than the number 3. So interesting. So every number in this spoke, and that spoke, and this one, and this one, and this one, and this one, this one, this one, is actually prime related, without exception. So I took this to Chapman University CEO, who we had lunch together. His name is Daniele Strupa, and he's a good friend of mine. I gave the commencement speech at Chapman. I was previously on the board of Chapman for a few years. And I gave their commencement speech for their 150th commencement in 2011. And he had heard from a mutual friend that had seen me while I was in Israel sitting next to him on a bus doing this prime pattern. And so Daniele is a famous mathematician, and so he called me. He said, Robert, he's Italian also. He says, I understand you have a prime pattern. I said, well, I have something. He says, can you show it to me? I said, yeah, sure. So we met for lunch. He was eating this stringy roast beef sandwich, and he's not a small man. And I showed him the pattern, and I said, what do you think? And he just goes, I said, Daniele, are you okay? And he's like, so I jumped around the table, and I did the Heimlich on him. And it didn't work the first time. I'm like, you got to pick him up, really. And so I had to do the Heimlich on him twice, and then he spits out his stringy roast beef. And I said, oh my gosh, I'm so sorry. Are you okay? Are you okay? And he says, back to the primes, back to the primes. And so we end up finishing the conversation. He says, you have to publish this now. You have to publish this now. And he actually, I said, can you help me write the proof so that it can pass muster with the other mathematicians? Because I hear these guys are not that nice. So he writes back that after he says, here's the proof, here's the proof. And so I ended up publishing it. And so what we found was that if you can generate the quasi-primes, then you can basically find and predict all prime numbers. Because we can now create what's called an exclusion criteria, which means that it's kind of like this. I guess the best analogy I could think of is that let's say we really want to understand matter. And so we all spend our time trying to understand what is the nature of matter, why is carbon the way that carbon is, right? But maybe the answer is not in looking at the carbon, maybe the answer is understanding the space around the carbon. So by analogy, I did the exact same thing. I figured out how to calculate and create a list of all of the green numbers. I don't have to look at any of the other numbers outside of that, which the sieve of Eratosthenes requires you to do. The way that it's been traditionally done to find primality is to calculate all numbers, multiply them all, and then take out the ones divisible by 2, take out the ones divisible by 3, take out the ones divisible by 5 and 7, and then what's left, right, you can say would be prime. Okay? Now I don't need to do that, so I can take out 2/3 of all of the event horizon of space, and I can find that just by placing them on this chart. Very simple spiral. And interestingly, no one had ever seen it before. No one had ever done it that way before. Now the primes, being on a chart like this, was first written about by Peter Plichta. But I think this is much, much older. Much older. You can go back and see that Templar cross design on stela in Sumeria. And it's all over Egypt. And it's embedded within the flower of life. In fact, you could say the Templar cross is probably an abbreviation for the flower of life. So how would you do this then? It's as simple as this. You simply take the numbers in those spokes on the x-axis and y-axis, you multiply them by each other, and the ones that show up in this body of the table, and of course these would all be the squares, right, would by definition be quasi-prime. That means they're divisible by prime, but they're not prime. And the ones that don't show up in here, but do hold a place up here, must by definition be prime. It's as simple as that. So for example, 25 shows up here, therefore 25 is not prime, even though it holds a place here. 35 is also 5 times 7, so therefore it is not prime. But 41 does not show up anywhere here, therefore it must be prime. So no one believed me on this. It was really funny because everyone just said, oh, it's too simple, too simple, too simple. So I said, just do it, just try it. And then within 2 seconds, we had the first trillion prime numbers accurately predicted on a laptop computer. So this was the chart, and it continues on infinitely. So constants emerge from their prime counterparts. The primes are on the outside of them. They sort of give birth to them, and they are from geometry. So I want to basically just show you this as well, that these constants result as waves overlap and hit each other. As these waves overlap and hit each other, imagine you have two pebbles that are dropped in a still pond. Waves will overlap, intersect, smash into each other, and create geometry, and math constants emerge off of those. And it's the same thing here. These are all just my hand drawings from this discovery process. Now, Alan Green had actually helped me to put together this video for this, and I'm going to show you just in just a moment. And basically, what's really happening here is that all math constants are all just transformations, very simple transformations of the number 1, all starting from this mysterious number of 137 again. This mysterious number of 137 relates actually to the most mysterious number in physics, which Richard Feynman referred to as the number we don't understand how God pushed his pencil on it. It is the most mysterious number. And so what I've been able to do is then take this and find totally new equations for these numbers that are fundamental math constants right here, because all constants relate to all other constants. It's just like each of us. We're not really all separate. What you're really looking at is a prism. When you look at one facet of that prism, it could be pi. You turn it slightly, and it's Euler. You turn it again, it's phi. You turn it again, it's alpha. This is a fundamental nature that actually all math constants are just coming in and out of the number 1. So with that,
out of the void came one voice, and the one became many, and the many became chaos. For they knew not their place within the whole symphony. Until, under the guiding principles of order, discipline, balance, measure, time, and harmony, the many remembered again their oneness. Could it be that science, hearing the sound of many waters within the seemingly chaotic interference patterns of our reality, has forgotten the art of listening for that one vibration? When circular waves encounter others, they create Vesica Pisces patterns within themselves. And this repetitive dance of duplication actually creates everything we experience in our daily lives. Science tells us it's all nothing but waveforms and mathematical probabilities. But in 2018, Robert Grant compared many of the known math and physical constants against their fractals or inverse decimal and angular values on a circle, expanding upon the study of quaternion symmetry. Nikola Tesla asserted that the secrets of the universe are embedded in the numbers 3, 6, and 9. And so Grant postulated the hexagonal integer 6 to be the center, the mirror reflection crossover point from which, radiating outward, numbers converge and overlap at various nodes. He hypothesized that numbers both create and emerge out of these wave propagations, and thus all constants manifest at the geometrical intersections between their x and 1 over x representations. The first of these conjunctions occurs at the center, where the golden ratio phi and its 1 over x little phi manifest. These are framed by the Euler-Mascheroni constant gamma and its close inverse, the square root of 3. The next conjunctions manifest fractals of pi and the Euler number e. These are framed by the cubed root of gamma and a light speed reference, c, against e minus 2 and a presently unknown new constant. The next conjunction manifests the squares of phi, framed by its square root and the fine structure constant, alpha, giving rise to yet another pair of new constants. At the Tesla integers 3 and 9, we find pi and its 1 over x fractal, which reveal 3.1623, a most significant balance between pi and its inverse, producing 2 more brand new constants. Moving further out, each subsequent framing simultaneously converges and diverges like concave and convex lenses, concentrating and dispersing energy. Thus we can see visually how the separation of light and dark is achieved mathematically. And perhaps we begin to understand more fully how the Einsteinian concept itself of space-time emanates from precisely such a dynamic wave function. As already shown, this new understanding predicts that at each halving of a wave, another mirroring constant must inherently result from the convergence. We are therefore able to predict with mathematical certainty where new, presently unknown constants will be found along an infinitely ever-expanding wave. Thus, from a simple x against 1 over x analysis, a unifying mathematical theory emerges, revealing an elegant structure hidden within an age-old mystery. since all the major constants, pi, phi, e, alpha, appear at these convergences, and presently unknown constants are now geometrically predictable, we see they are all pure quaternion reflections of the most fundamental constant of all, the integer 1. These findings even suggest that ancient references to a voice of many waters may literally be an accurate metaphor, developing a unique variant of the original Pythagorean tuning, which postulates that true A above middle C should be 432 cycles per second, or hertz. Grant has found that the musical notes themselves emerge from the intersections of these overlapping waves. Their hertz values correspond exactly to their angular relationships on a circle, requiring only minimal equal temperament adjustments to become a viable tuning alternative. And thus we have come, one might say, full circle to the pure, balanced alchemy of science and art, resolving the chaos of the many back into the unity of the one.
Thank you very much. I would just like to recognize my friend Alan Green for making such an incredible video. We're going to be presenting again at 1 o'clock. You do not want to miss this. Alan is just, as you all know, because I know he's been to several CPAKs, but he's just an incredible presenter and also an incredible human being, and also my very, very close friend now for the last year and a half. It's been kind of amazing, but thank you so much.